Let's have a look at integration. And again, though this question seems or look like a little bit complicated, but actually from the point of integration is not. The logo for the company is shown on the coordinate diagram below. The logo is the region enclosed by three curves defined by the following functions, C, S, and K. So let's have a look at the function and the logo. So we have C function, and we can see it's simple quadratic function. Where is that C? This one here, as you can see it is a parable. That's my C. Then we have S function, and that is this one here. Again, it is a quadratic function. So here we have only part, but this function will keep on going. And then we are told that K is the image of S, meaning it's exactly the same on the axial symmetry in the y-axis. So that means if I took that green one and folded over the y, so that means let's mark that. So that is this one here. That is the next one. Yeah. So you can see it three quadratic. Now, one thing we have to remember that quadratic is symmetrical function. So if I draw the axis of symmetry exactly in the middle, I can fold it exactly the same. So what do we need to do? Use integration. Now, they are very good to tell us that it's integration we need to do to work out the area of the logo. Now, integration, because that's what integration is used. If I am looking for the area between two curves, and that's what I have here. And here they are saying hint, find the area of the logo in the first quadrant and then double it. First quadrant being that. So first we are looking for this area, and they are saying then double it. Why? Because they are symmetrical, both three of them quadratic. Therefore, this area is exactly like this area. So it's enough to calculate 1. Now, how do we calculate the area between the curves? So it always within the interval, so B and A interval. And then first we consider which function has the high values minus the function that have low values. Now, what do I mean by high values of the function and low values? Value of the function is the value of y. So if I pick now, let's just pick a different, let's pick red. So if I pick, let's say, for this value of x, this value of x, so this function, the blue one, this will be the corresponding value of y, isn't it? And then for the green function, this one here will be the corresponding value of y. So obviously this value of y will be higher than this value of y. So this blue function, which is my c function, so that will be the c function that will have lower value of y, and then the higher value, so this one here will be the s function. So we need to first subtract them, and then we can integrate. Okay, so let's write it down. So we are saying we are integrating. Now, what's our interval? That's what 0, and all the way here we have 1. So 0 and 1, 0 and 1, always lower at the bottom, higher value on the top. So A is always lower, B is always higher. And first thing, we need to take away those functions. So S function is 2x minus x to the power of 2. So 2x minus x to the power of 2 minus, and then the second function c, and second function is x to the power of 2. Now, this example is very easy, so we're not going to make a mistake. However, what I want to point out to you here, if that function was a little bit more complex, let's say x squared plus 5, when I'm taking it away, it will be minus x squared minus 5, because it's the whole function that I take away. Very often, I'm always saying, you know what, put minus and then the second function in the bracket. So that just will remind you that it's actually that minus goes for each element of that second function. And then we are writing the x, saying that this is a derivative. So in the first instance, we can just deal with these values inside. So we have 2x minus, and then we have 2 of x to the power of 2 and then dx. What we are saying with this description is that we are going to integrate within that interval between 0 and 1, meaning that interval describes the values of x. And then this is the function that we treat as derivative. That dx at the end means that the function in the bracket here is a derivative. So in the first instance, we are saying we're going to integrate. In the next part, what do? We integrate. Now, what does that mean? We are applying formulas. So again, the same way we differentiate each element here, again, we're going to be integrating each element. And the same, we go to our tables, the same as it is with calculus when we find the formulas, the same here. Our elements are simple, so it is that very first formula, again, that we're going to be using for integration. So if I have x to the power of n, then we have a fraction, power plus 1, then power plus 1. Remember, with differentiation, we go down in power. 3 become 2, 2 become 1, 1 becomes 0. But with differentiation, with integration, because it's a process reversal of the process of differentiation. So I'm going back, I'm reversing back the process of creating derivative. Here, the powers goes up. So 2 will become 3, 1 will become 2. And then what happens when with the number in front of x, the coefficient, the same way it was with calculus, with creating derivative, it crosses over. Okay, so let's apply that here. So 2 will cross over, then I have a fraction, x on top of it, power plus 1. My power here is what? 1 plus 1, therefore, and at the bottom exactly the same, 1 plus 1. Minus, and again that 2 crosses over. On top of the fraction, I have x to the power of 2, and again that power plus 1, so 2 plus 1, and the same thing at the bottom, 2 plus 1. And then we are saying within that interval of 1 and 0. So we've applied our formulas. We can simplify that a little bit further. So it's x to the power of 2 over 2 minus 2, x to the power of 3 over 3 within that interval. And here that 2 will simplify out. So I'm just going to have x to the power of 2. Now in the next stage, now that I've integrated, in the next stage, I'm finding the value. And in order to find the value, I take the function and I replace x with first the higher interval. So in this case, 1. So we're going to have 1 to the power of 2 minus 2 multiply fraction 1 instead of x to the power of 3 over 3. And that again minus, and again our function. But this time we're replacing x with the lower interval, in this case 0. So it will be 0 to the power of 2 minus 2 multiply fraction line instead of x, 0 again to the power of 3 over 3. Now, yes, you are right, there is a lot of zeros here. Now, let's not forget about the hint that they told us that area, all of that area multiply by 2 because they are both exactly the same. And when we put all of that in our calculator, press equal, we're going to get 2 over 3. Okay, now let's have a look at second part of this question. Okay, part 2. The function k can be written in the form. So that form is the form of what? Every quadratic equation, isn't it? Where b, c are constant. Now, it is missing a, but they already gave us is minus 1. And the reason why we know that, because the graph of this function goes down, therefore it has a negative value of a. So now we have to find the value of b and c, the other coefficient, the other constant. Remember that k is the image of s on the axial symmetry in the y-axis. Okay, so how do I find it? So what are the information that I know? Well, looking at the graph, first thing that I know that this graph will cut or is cutting the y-axis at 0.00. So because it is cutting the y-axis at the value of 0, well, that means that the value of c here will be 0. Okay, so that means, let me just write this function again, minus y is equal minus x to the power of 2 plus bx. I need to find b, so if I have value of x and y, then I can sub that in. what does the x and y in every function represents? Why we have letters? They represent the point of the coordinates of every point that create that function. So if I have a coordinates of one point, I can replace x and y and therefore have one letter and solve it. So by looking at the graph, can we figure out one point? Well, yes, we can. We have here and here, right? This point here has coordinates of what? -1 and 1. So we can use that. So the point is -1 and 1. Therefore, value of x -1, value of y 1. Now, now I can just replace it and solve it. So instead of y, I'm putting 1 minus, and instead of x, I'm putting -1 to the power of 2 plus b, and again, instead of x, -1. Now, simple enough, but a lot of minuses. But we have calculator. It works. So if I put minus and in the bracket -1 to the power of 2, make sure you put that -1 in bracket, otherwise you're going to get the wrong value. We're going to get -1. And b multiplied by -1 will be -b. So numbers one side, let's say I move that one to the other side, change the sign, therefore 2 is -b, but I want b, not -b. I multiply both sides by -1, and -2 is b, and we already know that c is 0.